All right, we're going to talk through the wave properties homework that was at the end of the notes packet. I just put it onto a new document here, and this key will be uploaded to Schoology as well, but it's a nice quick walkthrough for you. So in a transverse wave, as you see here, the particles move perpendicular, or we could say opposite, to the wave direction. And what we mean there is as the wave moves left to right, the particles move up and down. That's what we see. One example of a transverse wave, you could put a lot of stuff here. If you have questions whether yours is acceptable or not, I'm going to put light because that's a really important type of wave for us. And in longitudinal, it's just going to be the opposite of this. So I'm going to copy and paste this in down here and then change it. It's parallel or same to wave direction. Okay. Part 4, label the crest to crest, trough to trough. Both of those are wavelengths, and amplitude is anywhere from midpoint to the top of a crest or bottom of a trough. Number 5, blank is the number of wave crests to pass. So it's the number of times that a crest will pass in a certain amount of time. That would be the frequency. And the time it takes is called the period. Okay. So buzzer has a frequency of 100 hertz. So this is the equation. I want period right here, which is 1 divided by frequency. So frequency is equal to 100 hertz. And what I have here is that period is equal to 1 divided by frequency. So period is equal to 1 divided by 100, which is equal to 0. My mental math here hopefully is correct. I'm just going to do it in a calculator, just to be sure. 0.1 seconds. So period is measured in seconds. Which medium particles are closest together means it'll travel faster. That's metal. Water or metal. Metal particles are still faster. So it's metal. Wave has a frequency of 40. Okay, so that's what I got here. Frequency is equal to 40 hertz. Wavelength, which is lambda. Ooh, probably don't know how to put a lambda in. Let's do it this way. I'm just going to insert a symbol here.
Hi.
Hey.
Picking up my binder.
That's fine. Okay, sorry about that. I had to pop in here. So the wavelength is 1.5 meters. And then if I want wave speed, I covered up. It's frequency times wavelength. Okay, so this is equal to wave. So my equation ends up being velocity or wave speed is equal to F times our wavelength. So when I plug it in, what I end up getting is this. I'm just going to do it underneath so you can see. Wave speed is equal to 40 hertz times 1.5 meters, which is equal to 60 meters per second. And that is my wave speed. So if you have any questions about that, let me know. Tomorrow we're going to try some more problems to get some more extra practice. Bye.